This is K8BYP with the fourth video in the Mixer Balanced Modulator series. Video number 4, K8BYP with underscores at IEEE.org if you want to email me. Houston, we have a problem. We have a design problem. The purpose of this exercise is that the diodes in the bridge in a TR3 are 60 years old and they're not matched. They probably weren't matched just the greatest in 1962. And I've measured them with a diode test scale, and there's a considerable difference in the forward voltages. So there's no way they're matched. But the entire purpose of this circuit, and this is a simplification of what's in the TR3, is that that bridge is supposed to be precisely matched diodes. That leads to the term doubly balanced mixer, where the doubly means that this circuit nulls out both the carrier, which is coming in here, and also nulls out the modulation input, so that all that comes out through the transformer on the left is the two sidebands. The DC voltage input or the AF modulation coming in cannot go through the transformer in any significant degree. It's an RF transformer. So a significant AF current through the transformer could cause some problems, but generally speaking, that'll be rejected. So it is possible to use one diode to do this, and there's circuits out there for that. You can look on the internet. The problem is hiding here in this so-called carrier balance pot. The carrier comes from the carrier oscillator to the wiper of the pot, 200 ohm pot, and the procedure is to adjust that pot for a minimum carrier, and there's everything about that that's wrong. The first premise is a matched diode bridge, and if it is matched, then this is a balanced circuit. There's no reason to twiddle that pot unless something is wrong. And in this case, there is something wrong. The diodes are not proper. So the procedure is to adjust that pot to, in vain, try to compensate for mismatching the diodes, and it is impossible. And I proved in another video that that's a failure. There's no way to twiddle that pot and get that to balance. These here are 470 ohm dropping resistors to set the current to the transformer. If the diodes are off or those 470 resistors are off, then that's going to require adjusting that pot to attempt to so-called balance it, but it's a failure before we even try, because the circuit is inherently out of balance. The real purpose of that pot is not to balance that circuit. That circuit had better be balanced all by itself, from the 470 ohm series resistors all the way to the left, to that transformer winding. The purpose of the pot then can only be to adjust itself. And that is, instead of trying to find two precisely matched 100 ohm resistors, half and half, to put them in series and center tap them with the carrier input. But it's then a given, if this circuit is precisely matched, and with these new surface mount Schottky microwave diodes, it will be, especially in that I've bought all the other parts, new surface mount precision 1% resistors and state-of-the-art coupling capacitor and all that. All brand new state-of-the-art surface mount parts, 1%, very high precision. So there's no reason to have a pot there to adjust, because I have 100 ohm precision resistors. Put two in series, replace the pot, and bada bing. Well, what I've done is I've actually complicated it for this experiment, and I've made the 470s variable also. And what I've done is I'm modifying the design to having two 1K pots, which are adjustable, so that I can not only precisely align that, but also vary the amount of current through the transformer. And also, instead of a single 200 ohm pot, I've gotten two 200 ohm pots. They'll be put here so that there's a further room for adjustment. So not only can this accomplish centering, but I can also shift the magnitude of that resistance. So that might bring some interesting results, and especially being able to raise and lower the amount of carrier input to this system. And increasing the carrier has had a tremendous advantage because, as I showed in the video short today, improvements here have resulted in a transmit power of 175 watts CW, which is tremendous. But now it has the correct amount of carrier drive where it was lacking before. And this is the start of the layout of that circuit on a pre-made so-called Radio Shack board. There are the 4 potentiometers, $4 a piece, and the itty-bitty teeny-weeny surface mount diodes in that static safe package. And the layout, you can see the diodes over here exaggerated in size. But that's going to be it. Very, very small circuit. And KBYP out till video 5.